Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Welcome back to another episode of the great Bill and Corey Show. Problem with vacation week, we had a best of last week.
Yes.
One of the problems is, customers take vacations too, so we get less questions.
That's true. Well, it actually helps us out to have a vacation week in that sense. Imagine if a Thursday show with only Wednesday questions.
Oh, yeah,
that would
exactly.
be tough.
So that would be a little tough there. So we're going to, Corey, you get to ask the first question.
Well, I mean, as our most rabid fans know, we had a best of Bill and Corey show last week because Bill's on vacation. So now I'm going to ask Bill, what did you do on your vacation?
Oh, thanks for asking.
And how
Corey.
was it?
Yeah, the vacation was fabulous. Except I didn't get to do the Bill and Corey show. But besides that, it was awesome. No, I went out to Colorado, did some hiking and backpacking in the Sangre de Cristo Mountains with some buddies of mine. And we're going to link that vacation with a little bit of tech talk here. So there's a couple things.
Were you Rocky Mountain High?
Okay. We're going to talk a little bit about volume versus standard volumes.
It's like how loud you hear something?
No. Just about gas volume.
Oh, okay, all right.
So, and we get questions on. Sometimes people will ask, they'll say, I need to know the flow rate at nitrogen at 100 psi, and then you got to think, do they want it? They want it standard cubic feet or they want it cubic feet. So let me try to explain that a little bit. So standard volumes are at sea level pressure, 14.7 psia.
70 degrees.
I'm
just saying the temperature is also part of it.
We'll get into the pressure thing. So it's like a normal, where most people live, down near the sea.
A comfortable good weather.
Comfortable. So versus if you're talking at 100 psi, we will give the answer in standard cubic feet. But if you compress the gas, then it's actually, it's different. So we're going to pretend this is a cubic foot. It's a cubic box. It's not quite a foot. But this would have like one cubic foot of air in it. Now, if you were to pump up the box, and if it held pressure, and you pumped it up, you could put another cubic foot in there. Mm-hmm. And it would still be a cubic foot, but now you'd have 2 cubic feet in there. Mm-hmm. So you could say it's a cubic foot at X number of pressure, or you could say it's so many cubic feet.
Yes.
So that's just a regular cubic. Most people just call it cubic feet. But if they ask it at a pressure, then you have to kind of explain to them. Then you come with the answer standard cubic feet.
That's where the whole SCFH as well.
SCFH. So yeah, most people skip the S because it's too much to say. But sometimes you need to clarify that.
Yeah. I mean, for the most part, when I see it, I just assume standard. That's what it always typically is, unless told otherwise.
Yes, but if someone says at a pressure, you're thinking, okay, if they're thinking it's at 100 psi and I got a cubic foot, it's like, well, wait a minute, you got a bunch of cubic feet in there. Mm-hmm. It's all compressed.
Mm-hmm.
Yes,
it's just smaller. You should have brought a smaller box or the Russian doll, the nesting dolls.
Well, that's coming up, not the nesting dolls.
Well, I mean that would have been good.
So anyways, pressurizing it's one thing. Now, I hiked up and camped at 12,000 feet, so it's kind of up there.
Humble brag.
No, it's not a big deal. But it's kind of neat being up that high. So there's things that happen. It's harder for you to breathe. Mm-hmm.
Or so they say.
Yeah, well, it is. So I'll bring it next time.
I've been up there.
So when you're up there, reason why it's harder to breathe is you get air pressure on us. It's 14 psia. You don't really feel it; it just feels like nothing. But it's really the weight of the air, the whole atmosphere pushing down on you. So if you're higher up, there's less air above you, so it's less pressure. So at that elevation,
and gravity goes down at higher elevations as well.
Yeah, well, that's.
I'm just saying another point. Gravity lowers as you get away from the Earth's crust.
Okay. Anyways, so I checked on NIH. So part of it is hard to breathe. So I found on the NIH website. They talk about your typical breathing in is half a liter. So this is half a liter, 16.9 ounces for people who use English units.
So humans have a flow rate as well.
Yeah, so when you're breathing, you're going to be pulling in, and that's all you can pull in. Mm-hmm. It's not like, oh, wait a minute, we're higher, I can pull in more. So you're pulling in this much, and what you're getting in air is really that much air.
At elevation.
Well, it's really 11 ounces. This is a 12-ounce can, so it's...
It's not perfectly to scale.
It's not perfectly scaled. So we just kind of put perspective on it. You'll see it. So your lungs are saying, I need half a liter, and the air is saying, sorry, you're getting 11 ounces instead of 16. So that's why you're going to be breathing more at elevation, because you're trying to get that oxygen. You need that oxygen for your body to work and stuff.
That's what they say.
And the NIH calls it, instead of like standard pressure, so they call it tidal volume, which is kind of, I never heard of that before.
Does that have to do with the moon?
No, I don't want to get into that. So when you're at elevation, you're kind of like under a vacuum. So it's kind of like there's a, you don't have the air pressure. It would be the same if we were here and there was a big vacuum sucking the air out of the room. Get a little bit out of there.
So, and to add to that, I know you Scott, but back in the day when I used to work for a different company that made ASUs, we had to take into account elevation when doing calculations because it affected pressures and flows and things of that nature as well.
Yeah, yes, because scientists...
So it can be important.
Scientists always look at the PSI-A.
Yes.
Because that's how you figure everything out with your gas laws and everything else. Yeah, and that elevation is taken into account. Because it's like 9.3 something PSI-A at 12,000 feet versus 14.7 at...
So if you want to lose weight, weigh yourself at sea level, then climb a mountain.
Well,
and then weigh yourself afterwards and you'll have lost weight.
Okay. We're getting derailed here. The other thing that happens is sometimes you'll see on packages that if you're cooking at an elevation, it's going to take longer. That means it's probably going to taste worse. So boiling temperature of water at sea level is 212 degrees Fahrenheit or 100 degrees Celsius or centigrade, depending on how you want to deal with it. So if you're up at, like, regular people can live at 5,000 feet, so like in Denver or
Those
something.
normies.
So your boiling temperature, so you're trying to make your spaghetti or whatever, instead of 212, it drops to 203 Fahrenheit.
So you can save energy boiling water
Yeah,
because it boils at a lower temperature.
But then it's really not as hot because you really want to cook spaghetti at 212.
It just matters if it's boiling or not. I don't.
But then you go up to 12,000 feet, then it drops to 190 Fahrenheit, 88 C.
What?
So you can see that's a lot cooler. So it's really like...
What elevation do I need to get to where water just boils?
No, well, it depends on the temperature, and I had a chart there. So it's the higher up you get, it just, so yeah, it gets... So
are clouds just pockets of boiling water? Is that?
No. We'll get into that stuff. So what does this mean for anything? So who cares? So it boils off. What does that have to do with like our stuff? Well, if you got, let's say you got a cylinder, and cylinders sometimes they clean them out with like an acid wash or something, or they need to be retested, and they're usually hydro tested, which means they use water. And you got a cylinder that's full of water, and you want to have gas in there that's going to be like 1 ppm moisture. Well, I mean, you could just take the valve off, dump it out, but it's still going to be wet in there.
Yeah.
So you got to get that out. And you just can't, it's not like at home you just turn the glass over. It's got,
Put it right on the drying rack.
Put it on a drying rack. It doesn't work that way. So what you can do, you put it in what's called bake-out oven. And the bake-out oven, it'll heat it up, and you'll have a vacuum on there. So the vacuum lowers the vapor pressure, lowers the boiling point of the water, and then the heat helps.
Is that why we have a location at Longmont to save money on?
So that's part of it. So putting a vacuum on it will help evaporate the water out, and heating it up will help it. So you're kind of boiling, and it's really kind of on a almost microscopic level because you got little hydrogen molecules.
Well, yeah,
hiding in the pores and stuff
yeah,
like
water can enter the pores of steel. It's
that.
crazy.
Okay. So I think we kind of chewed up enough time on my vacation. So
I'm glad you're back.
Next question is on the 8590 controller, and this one's for Corey.
I mean, it's sort of for Corey. Don't. So it made me think. Is this what we're talking about?
No, it's not that kind of controller.
This is a PS4 controller, not an 85. Okay.
No, that's not what it is.
All right. I should have picked one that's not camouflage. I hope they can see it at home.
Okay.
So, the 8590 controller.
This is not it.
This is not it either, but this is the newest version of the 8590
The
controller.
8590 we did in the
80s?
early 90s.
Early 90s, yes.
Yeah.
So it's been a while. It's been a.
That's not why it's 8590, because it was 90. It could have been, but I don't think so.
Wow, we should start naming these after the year they were used. I'd make it and be like, oh, that's the 2003. Oh, it was used in 2003. No, so this is essentially an electronic switchover.
Yeah, and this is the Pro 201, which
Mm-hmm.
is obsolete. So we went to the 8590, and then we went to the AS 200, and then we went to Pro 201.
But in all reality, it's whatever is the
Current model.
the current model, because
Yeah.
we don't do them that often. That
Well, we got the current one there.
yeah, whenever we do a new one.
So
yeah,
we just had to have that laying around.
yeah, it doesn't really sit nicely. It's got
No,
some.
well, it's made to put on top of a cabinet.
Yeah.
And then you could hook everything inside the cabinet without having to penetrate the cabinet. So it's kind of
These would penetrate the cabinet.
Yeah, I know, but if you're wiring up and stuff, you just
I know, it
plug
makes it
things in
sealed
there.
and nice. You know,
So this
even
is
sealed.
this looks like our current AS.
And it looks just
Our
like what?
ASC too. It looks
Just like a GSM 12.
exactly like a GSM 12, because this is a GSM 12. But it's the same box and same kind of layout.
You change the circuit board,
And,
wired
yeah,
up
they-
differently.
Yeah, and they put another set of
Different
solenoid
face
valves
on
in
it, I'm assuming.
Yeah.
And then because why make a brand new box when that box can work multiple
Yeah,
places.
yeah, you can use it for multiple things.
And so this is for really special occasions where a regular automatic pressure switchover that we use will not suffice.
Mm-hmm.
And so this one will take signals from, say, a scale
Mm-hmm.
or an IPS, one of our gauges that has the wires coming out that sends signals saying it dropped below 300 PSIG. So if it drops below a certain thing, the scale or the IPS will send a signal to this to switch over to the other tank, essentially, the other cylinder.
Yeah, and it controls it back and
Yeah, it controls
back
it
and
back and
forth.
forth.
So
Not as economical as a pressure switchover, but it does work really well, and we use them when we have to.
yeah, yep. Okay.
All right.
I'll let you put that one down. I'll put this one down. Okay. Next question is on someone on a PG1000 with a valve on the outlet. And you're probably at home saying, what's a PG1000?
Everybody knows what they are, don't they?
Well, we got two, I think the P's for plastic. And so we have this is a PG1000, so P for plastic and G for glass. So it's an acrylic body, and it's got a glass tube in there. And so it's kind of neat putting it together. Yeah, so what we did was, and you can, they're typically like this, with a valve at the bottom, but this guy wants a valve at the top. So all we had to do was take the little glass tube in there, flip it around, and then you can use valve in the outlet.
Well, I mean, the key is you got to flip the tube around, otherwise, it would
be backwards.
Yeah, it would be upside down.
Now this is showing you the acrylic block. It's not so easy because it's tapered. This is the inlet this is where the valve goes on the bottom.
Or in the top in this case in the future.
You can't see it, but it's tapered, so it's like drilled out, machined out with a taper on it. You put a float in there, and it looks like a ball, but it's not a ball; it's a float. And then, but you can't just flip it around because then your taper's the wrong way, and it won't work with the valve on the outlet.
Ah, so you can't just switch. You have to get one specially made.
Yeah, you could get a special body for that. I don't think anybody's ordered one in decades or something like that. So, I mean, not every rotometer can do everything. So you have to pick out which one works for your application. So if you really want a small rotometer with a valve on the outlet, you should go to their FM 1000s. Well, I don't have an FM 1000.
That's a bigger one.
Yeah, this is.
So
no,
about
it's about
half
the
that-
same size.
It's about half that size.
No, but this is the FM 1050.
Yeah.
And what's nice about these is you can easily flip-flop things around. You can change the valve comes out.
But these are direct read as well, right?
Yeah.
So whereas our FM 1100 is more direct read, which is also a shorter version, closer to it than this one.
No, the FM 1000.
Oh, what did I say?
Oh, the 1100. So yeah, these are
Okay.
FM 1000, a shorter
Yes,
version.
yes.
FM 1050. So you can do a lot of different things. You can easily you have wider variety of the inlet outlets, wider variety of valves, valve inlet, valve outlet, and the reason why you'd have the valve on the outlet is if you have varying downstream pressure, you need to know the pressure inside the tube to get an accurate flow rate. So, so if you have varying pressure downstream, you want to have pressure in the tube, and you say, okay, it's at 20 psi. That's my flow rate. I have to do a pressure correction factor for it. And downstream, it doesn't matter if that varies because it's the pressure in the tube. Okay.
Well, thank you, Bill.
And then we got time for. Oh, I didn't bring a regulator for this one. So.
That's okay.
So this one is, we get
we
these
have a
questions a lot. Corey gets these questions a lot.
Yes.
He gets the fun answer. So sometimes people call on a pressure regulator to regulate flow.
Yeah, so this is a common question I have, and I know I've touched on it a few times talking about, oh, this is an old, that one's from the museum, our carefully curated museum.
Yeah.
So, I mean, so this is a flow meter. So people constantly call me and ask, like, you know, the flow coming out of my regulator is too high. How do I lower the flow? Well, and I try to explain to them, a regulator regulates pressure. It doesn't do anything to flow. Even though theoretically you could. If you have a lower pressure going in, it's not going to flow as fast coming out. So, but you don't really want to order bottles of nitrogen that are 1,000 psi-G, I think, for whatever reason, because it makes your flow nicer coming out. So in all cases, I just want to, we have two options for it. We do sell regulator flow meter combos, which are a great way to do that. So it's got a regulator and a flow meter or rotometer on it. And this guy's the thing that can change the flow for you really easily. This is a valve. You can get a high accuracy valve or a standard valve, and they can meter the flow. This is a...
Oh, we call it a calibration
That's
gas
it,
regulator.
yes. Calibration
but
gas
it's really a
flow regulator.
flow regulator.
Yeah. So this one actually does regulate flow. So some can do that. And this one's special. You actually have to, it has settings on it. Be like, I want this flow or this flow or this flow on it. So, or that flow. And what I'm saying is, it's sort of a preset flows loaded into it. Okay. And this guy right here is something that, I mean, honestly, I'm a little embarrassed. I just learned about it yesterday, and this is a great solution. So for people that are like, the flow's too high coming out of my regular, I just want a lower flow, tells me that they don't even care about the number. They just a lower flow that they want. This is the valve in our rotometer in just regular valve form. So you can meter your flow. It's a needle valve.
Yeah, it's 15-turn needle valve.
Yep, 15-turn needle valve. There's 6 ranges varying from 100 ccm to 30 lpm. And if you want to lower your flow, this little guy, just add him to the outlet of the regulator, and you can.
Yeah, you can really regulate it. So it's like a rotometer, but without the
gauge,
without the tube and the float.
So if you don't care what the actual number is, you just want it lower.
Yeah, that's a very accurate valve.
Yes. So.
All right. Well, we ran a little long today.
So our longest show ever.
Yeah, I know. So thanks for tuning in to the end.
If you did.
If you did. If you didn't, it doesn't matter. You're not listening to us. But thanks again for watching another great episode of Bill and Corey Show. We got another live episode next week at 10 a.m., so please tune in.
And set your VCRs.